Okay, now that we know the definition of statistical mechanical definition of in temperature, the thermodynamic temperature, the next question that comes to mind is whether that thermodynamic temperature can have a negative value or not. Now we know the definition, and that definition is this for this inverse temperature. And given this, we will now analyze this according to this definition. What can we say about this question? So for normal systems that we come across, usually those systems that we mostly come across, macroscopic system, they will have unbounded energy spectrum. What does that mean? That there will be infinite number of energy states available for the system. Okay, and that essentially means that for as you increase the energy of the system, the components of the system containing atoms and molecules, they will have more quantum states to occupy. More number of states are available. So the more you give energy, they will go to higher and higher energy states, and that is why that will lead to more number of microstates. W will be more, and automatically entropy will also increase. That means with increase of energy, entropy increases, and that means this quantity will be always positive, and that automatically means that slope of S versus E curve for such normal system with unbounded energy spectrum will be positive, and that means always for such system absolute thermodynamic temperature cannot be negative, it has to be always positive. Okay. Now let us come to systems which are effectively isolated system. So for some special kind of isolated systems for which bounded energy spectrum is bounded. That means there are finite number of energy states available for the system. For such systems, what happens is the system as a whole can have some minimum energy, and that minimum energy, let us consider that minimum energy is E minimum, and then it will have a few microstates or maybe one single microstate, in the sense that number of possible arrangement will be minimum. On the other hand, system can have also a highest energy, where suppose all atoms and molecules or whatever the subcomponents of the system, they are at their highest possible energy level, and in such cases the system's energy is E max, and then it is likely to have lesser number of arrangements, so few microstates. So entropy will be again small. Entropy will be small in the first case, entropy will also be not very large, it will be small at the second case, because W is also not very large. However, at some intermediate energy, these systems may have maximum W, number of microstates may be more. Microstates being more, the entropy also at that energy E star will be also maximum. When entropy is maximum, then that means this condition, according to that slope will be 0 at maximum. So at this E star, system has maximum entropy, so this condition will be 0, and that automatically means, let us see a schematic diagram. That means for a system, if we plot S versus E, then we see that at some minimum energy you have some value of entropy, and this is a schematic diagram, not in scale. At some intermediate energy you have a maxima through which the entropy passes, and then it again decreases. At some E max it has again a small value. That means you have this kind of schematic representation of S versus E plots. What it essentially means is that under the maximum, at that maxima E star, energy is E star, you have slope 0, that means 1 by T is 0, and that you can associate that the system's temperature is equivalent to something like plus infinity or minus infinity. It does not really matter, they are kind of equivalent. So temperature can be associated with infinite temperature in a way, plus infinity or minus infinity. However, from this curve we see what happens in this region where energy of the system, internal energy, is lesser than E star, at which there is a maximum entropy. So energy at lesser than E star, you will have a positive slope of this ds dE, and beyond E star you will have a negative slope of dst, and the consequence that automatically comes is that for energy less than E star, 1 by T, that the slope is positive, so 1 by T is positive, so system will have absolute temperature which is positive. However, when energy is greater than E star, at higher energy than E star, then 1 by T has to be negative, because the slope in this region is negative, and that's why 1 by T is negative. So automatically thermodynamic temperature can be negative for such isolated systems with bounded energy spectrum. So we will now see whether that can really happen. So that will be the next slide. Let me stop here.